Good afternoon, everybody. Can you let me know if you all are hearing me clearly, please, before I begin? Thanks. All right, so I'll begin right now. So today in this class, we'll be going through, this is our last lap, basically. This is my last review on vectors, right? This is my normal Form 5 class, but I've invited some other people as well, just to see how my classes are, all right? So in this class, we're going to be going through the concept of vectors. We're going to see how to answer some vectors questions, right? So let me start. All right, so the first thing you all need to understand, what is the concept of a vector, right? I know some of you all out there do physics as well. So we have two types of quantities. We have what we call scalar quantities, right? We have scalar quantities and we have vector quantities. Scalar quantities have magnitude only, meaning that they just have a number, right? So let's say the mass of a person is, let's say, 40 kilograms, right? So 40 kilograms, this is what we call a scalar quantity. It just has a number, right? It's 40. But we have something called a vector quantity. And what makes something a vector quantity has to do with the fact that it has magnitude, but it also has direction, right? So a vector quantity has magnitude and direction. This is a key concept you need to know. Now, a vector typically is represented using an arrow, right? So the length of the arrow represents the magnitude or the size of the vector, right? So remember I said a vector has magnitude and direction. So if we are using an arrow to represent a vector, the arrowhead is going to tell us the direction of the vector, and the length of this arrow is going to tell us what the magnitude is, right? So an arrow can be used to represent a vector. Now, we can represent vectors in different ways, right? So let's say we have a point, let's say O, and we have a point A. We join the points O and A, right, with a straight line. That straight line represents a vector, and that straight line represents the vector called OE, right? This is just one way how we can represent a vector, right? We have the starting point. So the starting point in this case here is O. We started at the point O, and we're going to end up at the point E, all right? And we put a little arrow on top there, and that is one way we can represent a vector, right? Now a vector can be represented in different formats, right? One format that CXE commonly uses is a column vector format, right? Which is this format here. This here is the column vector format. So, and in an exam paper, you might see something like this. The vector OA is represented as a column vector, which looks like this. Let's say 3, 4, right? That's what we call a column vector. It consists of two values, one on top of the other, right? Another way we can represent a vector is by using something called a unit vector, right? So OA can also be represented by a solid common letter, right? So this vector OA could be represented as just a small e, right? Which is solid. So vectors can be represented in different ways. So I can represent the vector OA I can do this. I can say the vector OA can be something like, let's say 3, 4, right? I'll tell you what these numbers mean in a sec. Or I can say the vector OA is represented by an E that looks like this, right? Those of you who are doing add maths, you might see a vector being represented by something like, let's say 3i plus 4g, right? That's another way of representing the vector. Or we can represent the vector in terms of a and b as well, right? So for CSEC Maths, we don't really see I and j, but we usually see a and b, or p and q. So this will be something like 3a plus 4b, right? So these two are, we're representing the vector using something called unit vectors, right? Now, let's get to something that is pretty important. I need you to understand this concept to understand what those numbers mean, right? So we have something called position vectors, right? Now, position vectors are vectors relative to our origin on a graph, right? You know, when you're drawing a graph, you have your x-axis and your y-axis, and where those two intersect, that point is called my origin, right? That's this point here. This is my origin, right? Now, why is this doing this? Now I have 4 different vectors being represented here. So let's look at something here. From this point to this point here, if I join those 2 points, that vector is called OE, right? From the origin, again, to the point B, which is here, right? That's our next vector, and it's called OB, right? The point C is across here, and if we start at the origin and we move to point C, that vector is called OC, right? We have another point here, we're going to call it D, and we have the origin here. So from O to D, that vector is called OD. These vectors are called position vectors because they are relative to the origin, right? The origin is this point here where the 2 axes meet, right? I just want you to understand the terms. Now let's try to understand what the numbers mean now. Now, all right, so we have a vector here which is starting at O and ending up at A, right? So that vector is what we call OA, right? So we write it like this, OA. Now, sometimes in a question, they might give you a diagram like this, and they might say, write down what is the column vector for the vector OA. In order to do this, what we need to do, you need to understand this in terms of where am I starting and where am I going to end up. So I'm starting at O. Now a column vector looks like this. It has 2 values. The value on top gives us the movement in my x direction, or my horizontal movement, and the number below gives me my movement in the y direction, right? So look at something here. So I want to start at the point O, but I want to end up at A. I must always move in the x direction first, which is horizontal. So look at this. Let me use a different color here. So if I go, look how many units I'm moving, right? I'm moving 1, 2, 3, 4 units. So I'm moving 4 units to the right. So I'm going to put the number 4 here. Then I'm going to go 1, 2, 3, 4, 5, 6, 7 units in the y direction, right? So the vector OA written in column vector format is 4, 7, right? Now the number 4 and 7, I'm getting those numbers in terms of my movement. So keep this in mind. We always move in the x direction first, and then we move in the y direction. So don't tell me that the vector OA, don't tell me the vector OA is, let's say, 7, 4, right? This is wrong. That is not the vector OA, right? I must move in the x direction first, then in the y direction. Okay? Let me just see if that makes sense to you all. All right, so let's make sure this is making sense before I move on. All right, cool. So we understand that. Now, when you have a diagram, like when they give you a diagram, right? In your mind, you must understand, you must set up a convention in your mind. Anytime I move to the right in my x direction, it's a positive value. If I move to the left in the x direction, it's a negative value. If I move upwards in the y direction, that's a positive value. If I move downwards, it's a negative value, right? Just like how on a normal graph, that's what we do, right? So let's look at this one here. So in this case here, we have the vector OB, right? So this is my starting point. So I want you to understand it in terms of starting point and ending point. So this is O, and this is the point B. In order for me to go from O to B, right? So O to B, as the vector we trying to write down in column vector format, right? I mean, I know the answer is right there because I have the slide up. But let's understand what's going on. So to go from O to B, I must move in the x direction first. Keep that in mind. So you're going to go 1, 2, 3, 4, 5, 6 units to the right. I'm moving 6 units to the right, so therefore that number has to be positive 6 basically, right? Now, in order to get to the point B, I have to move 1, I'll use the green color here. I have to use 1, 2, so I'm moving 2 units downwards. If I'm moving 2 units downwards, it means that this number here has to be minus 2. So direction is important when we are trying to write a column vector. All right. So the vector OB is 6 minus 2, right? So obviously I'm going to give you 4 different examples here. Let's look at this one now. So in this one here, we want to find the vector OC. So this is the point O, this is the point C, right? So I want to get the vector OC. So in column vector format, you're going to have 2 numbers. So let's figure out what the first number is. So I must move in the x direction first. So I'm going to move 1, 2, 3 units to the left. Now I'm moving to the left. If I move to the left, it has to be minus 3, right? And then I'm going to go 1, 2, 3, 4 units upwards. Because I'm moving in the positive direction, it's going to be just 4. So the vector OC is minus 3, 4. All right? And the last one, I want to get a vector OD. All right, again, we need 2 numbers to represent this vector. So I'm starting at the point O, and I'm going to end up at the point D. So I need to move 1, 2, 3, 4 units to the left. If I'm moving to the left, then it has to be minus 4. And then I'm going to move 1, 2, 3 units downwards. So if I'm moving downwards, it has to be minus 3. So the vector OD is minus 3, right? So just to summarize what I'm saying, right? So any movement in the y direction, any movement in the, if we move to the right, right, in the x direction, the number is going to be positive, right? The number is going to be positive. If I move to the left in the x direction, right? If I move to the left in the x direction, the number is going to be negative. And the same concept applies to the y direction. If I move upwards, it's going to be positive. If I move downwards, it's going to be negative, right? So I'm just going to ask, make sure you all understand that. So if in your exam, if they give you a diagram and they ask you what is the column vector, that's what you have to do. You start your movement in the x direction and then you do the movement in the y direction. All right. So let's see, where do we move on to? All right. So we've been talking about column vectors, right? And position vectors. Now, we have something called the magnitude of a vector. Now, at the beginning, I said a vector has both magnitude and direction. The magnitude of a vector is simply the size of the vector, right? But if you notice, in the 4 examples that I just gave you there, every single time we drew a vector, what we were actually creating is a right angle triangle, right? You are always creating a right angle triangle, right? And this is my 90-degree here. Now, you all should have done something called Pythagoras' theorem, right? So those in my class, we went through this a while back. So we have something called Pythagoras' theorem. Now, Pythagoras' theorem only applies to right angle triangles, right? So if I have a triangle like this, and this is a right angle here, let's call this length C, let's call this length A, let's call this B, right? Now, in class, I usually tell my students, I don't like to learn all formulas. So if you want to know Pythagoras' theorem, learn it off in terms of my longest side, or my side opposite the right angle, is called my hypotenuse. So how you should learn it off is like this. My hypotenuse squared is equal to the sum of the squares of the other 2 sides. The other 2 sides are A and B, so therefore it's A squared plus B squared, right? Because in the exam, they can label the triangle anyhow they want, right? And if you learn it off as, let's say, A squared equal B squared plus C squared, some students actually get confused when they see a diagram and it's labeled differently. So learn it off like this. The hypotenuse squared is equal to the sum of the squares of the other 2 sides. So my hypotenuse in this triangle here is C. So it's C squared equal to A squared plus B squared, right? That's the whole concept with Pythagoras' theorem. Now, if you want to find the length OA, right, or the magnitude of this vector, oh, by the way, we represent the magnitude of a vector using this, right? You put the vector OA, this is the vector, and you draw 2 vertical lines on either side of the OA, or either side of the vector, right? That is called the modulus of OA, right? And that's how you represent the magnitude of a vector. So in the exam, when they ask you for the magnitude of a vector, that's what you're going to write, right? Now, all you really need to do to find the magnitude of the vector, you need to know how many units you had moved in the x direction, how many units we had moved in the y direction, and we're just going to plug it into this formula here, which is essentially Pythagoras' theorem. So if we knew that c squared is equal to a squared plus b squared, it means that c is equal to the square root of a squared plus b squared. And if you notice something, well, that's essentially what the equation is, right? So to find the magnitude of a vector, it's simply the movement in the x direction squared plus the movement in the y direction squared, and we find the square root of that. So what you're really using here is Pythagoras' theorem. So let me give you an example of how this works, right? So look at this question here, all right? You are asked to find the magnitude of the vector AB. Now the magnitude is the size, is the length, right? That's what magnitude means. So first things first, let's write down what the vector AB is in column vector format for me, right? So I'm asking you all, what is the vector AB? Give me the 2 numbers. Give me the x number and the y number. All right, so I'm seeing somebody saying x is 3, y is 4. Everybody else seeing that? All right, so Xavier saying 3, 4. All right, so you all should be able to recognize what the column vector is, because look at something here. You want to go from A to B. So we're going to go in x direction first. So this is 1, 2, 3 units to the right, so therefore that has to be 3 here. It has to be positive. I'm moving in the positive x direction. Then I'm going to go 1, 2, 3, 4 units in the positive y direction. So therefore, this here is what my column vector is, right? Now, here's how you're going to write up your answer now. So the question wants the magnitude of the vector AB, right? So we're going to write magnitude as this. You put AB and you're going to put the two vertical lines on either side, right? You don't necessarily have to write down any formula, right? But you already know what my units are. This is 3 and this is 4, right? And you could also see it across here. You can see it here in the column vector. So all I'm going to do, I'm going to say 3 squared plus 4 squared, and we're going to find the square root of that. So 3 3s are 9, 4 4s are 16, 9 plus 16 gives me 25, 25, square root of 25 gives me 5. Now keep in mind, when you have to work this out, you're going to put 5 units, right? We're not going to say centimeters, we're going to say units. So the magnitude of this vector here is 5 units, right? So if you were given a question like this in your paper 2, the written paper, this is how you're going to write out your answer. If they give you a diagram, so they can do one of two things. They can give you the diagram here and ask you to find the magnitude of the vector, or they can just say, here what? This is what the column vector is, find the magnitude of the vector. Just now, huh? So let me ask you something. Let's say I have a vector. Let's say a vector CD is equal to, let's say, 6 and 8, right? So if I have a vector CD and the vector is 6, 8, I want you all to calculate for me what is the magnitude of the vector CD, right? What is the magnitude of the vector CD? Alright, so I'm seeing you're getting 10 units. So all we're going to do, we're going to apply the formula again. So it's going to be 6 squared plus 8 squared. Find the square roots. 6 6s are 36 plus 64. Find the square root. 36 plus 64 is 100. Find the square root. You're going to get 10 units. Right? So that is how we find the magnitude of a vector. Alright. Alright, so this was just the written solution for the last one. Now, I mentioned this before. There's something called a unit vector. A unit vector is simply a vector that has a magnitude of 1, right? So if you ever see this in your multiple choice or even the paper 2, right? A unit vector is simply a vector that has a magnitude of 1, right? So if we had a graph like this, a unit vector could be from here to here, right? This is a unit vector and we're calling this vector A. So A is called a unit vector along the x-axis. B, this is a unit vector, it has a length of 1, right? So B is called a unit vector along the y-axis. Now, you need to understand the concept of unit vectors, because if I have a vector, let's say OA, right? We just met OA and we said OA was 3, 4. I can write the vector OA using unit vector format. So I can say the vector OA could be 3A plus 4B. That's another way of writing a vector. All right. So let me see. What was my next thing here? So this here is a typical examination question. They give you a diagram like this, and they said unit vectors, A and B are unit vectors as shown in the diagram. The question wants us to write down what is the vector OA and what is OB in terms of the unit vectors. So I want you all to tell me what is OA. First of all, what is OA? I want you to give me the answer in terms of small a and small b. So what is the vector OA in terms of a and b? Look at the diagram. So we want the answer written in unit vector format, right? All right, so I've seen some answers coming up there. So we want to get, let's see what is OA first, right? So to get from O to A, so O is here, and we want to go to A. So we're going to go 1, 2, right? So you're moving 2 units to the right. So in terms of your unit vectors, it's going to be 2A, and then we're going to go 1, 2, 3, 4, 5, 6, 7. So we're going to go, and we're moving in a positive direction, so we're going to go plus 7B, right? So notice I didn't write the answer as 2, 7, right? This is column vector format, all right? This is a column vector. All right, but the question wants us to write it in terms of A and B, in terms of unit vectors, right? So this here is the answer. This is what we're looking for, right? This is actually an exam question, I believe, right? So that is OA. So since you understand what I'm asking for, I want the vector OB in terms of a unit vector. So what is the vector OB in terms of A and B? Alright, so look at the diagram and see if you can tell me what it is. Alright, so I'm seeing somebody saying 4A and 2B. Alright, so you want to go from O to B, so you're going to go 1, 2, 3, 4 units to the right. So if I'm moving to the right, it's positive, so it's 4A, and in order to get to B, we're going to go 1, 2 units upwards, so it's going to be plus 2B, right? So this is how I'm writing my answer, right? So this is what we want here. This is writing your vector in terms of unit vectors, right? So far, I've told you how to write a vector in column vector format and in unit vector format. For your exam, you need to know both of them. Now, let's do some simple algebra here, right? hold on, I'm missing a page here. Give me a sec. Alright, so I feel I was copying something and I feel I miss out a page, right? So let me just talk about something here first, right? So let's talk about scalar multiplication of a vector, right? I thought I copied it here. So now here's what scalar multiplication is, right? If I have a vector, let's say OA is equal to, let's say 2 minus 1, right? But I come and I tell you, here what? I want to know what is the vector 2 OA, right? So all I'm doing here, I'm multiplying the vector by 2, right? So how are we going to do that? You know what the vector OA is? OA is 2 minus 1. So all I'm going to do is take 2 and multiply it by 2 minus 1. Now, here's what you have to do here. Your final answer is going to be a column vector. But what you have to do is take this number here and multiply by the number on top, first of all. So 2 by 2 gives me 4. And 2 by minus 1 gives me minus 2, right? This is what we call a scalar multiplication. So in terms of, let me give you something that is general, right? So if you have something like this and the vector is xy, and I come and I ask you, what is the vector k times OA? The vector k times OA will simply be kx, ky, right? Simple multiplication. That's all we do, right? If I have a vector, now this is our next way we can write a vector. We can say A is equal to, let's say, minus 2 and 4, right? And I want you to write down the vector 3a for me. That vector 3a will simply be 3 multiplied by minus 2, 4. So I'm going to take the number 3 and multiply by this first of all, and I'm going to get minus 6, and 3 by 4 gives me 12, all right? So this is what scalar multiplication is. Does that make sense? All right, so that's scalar multiplication. So let me give you one to do. So let's say I have a vector A and it's given by minus 2, 6, and I want the vector 3A, right? So that's one. I want to get that. If I have a vector P, now a vector can be called any letter. P, let's say P is minus 2 minus 4, and I want to find 2p, right? So I want the first one. What is the vector 3a? All right, I'm seeing Joshua give an answer here. Anybody else? -6, positive. All right, cool. So seems you all understanding what's happening here. So if you want to get the vector 3a, it's going to be minus 2, 6. We're going to take the number 3 and multiply by minus 2. 3 by minus 2 gives me minus 6. And 3 by 6 gives me 18. Right? So this is my vector 3a. I want to know what is the vector 2p now. Alright, so I'm seeing answers minus 4, minus 8. So all you need to do, you're going to say 2 multiply by minus 2 minus 4. Oh, by the way, this is exactly how you're writing up your answer if you have to write it. So 2 by minus 2 gives me minus 4. 2 by minus 4 gives me minus 8. Right? So this is my vector 2p. Now, that is vector scalar multiplication. Now, vectors can also be added. So let's say I have a vector A, and this vector is 1 minus 2, and I have a vector B, which is, let's say, minus 2, 4, right? And if I ask you to find, now these are exam questions that you can be given. Find, let's say in part A, they want to find A plus B, and in part B, you want to find A minus b, right? Or even in part C, they can ask you to find a plus 2b. These are typical exam questions. Some of you might look at it and be like, oh wow, this is really easy. Or some of you will be like, I'm not sure where to start, right? This is very straightforward. If you want to find the vector a plus b, so let me work it out here for you, and I'll give you one to work after. So we have a. In part A, you want to find a plus b. So you're going to write down. Now, I have a problem with this, right? I like to see students write their answers properly, right? I just write crapperfoot, right? But when it comes to writing solutions, it needs to be written as clearly as possible, right? Now, the reason my writing is bad here is because I'm using a special tablet to write. I'm not using a mouse or anything, so it's kind of hard to write for me. It's not like it's like a pen, but it's still a little hard for me to write. So a plus b, right? This is how you're going to write it. So you're going to put a, the vector a is 1 minus 2, and the vector b, so you're going to add minus 2 and 4, right? That's how you're going to write up your answer. Now, all you're going to do now, you're going to add. You're going to add these corresponding values here. So we're going to say 1 plus minus 2, right? It's the same as saying 1 minus 2, which gives us minus 1. So that's the top part. Then we're going to deal with the bottom part now. Minus 2 plus 4. Minus 2 plus 4 gives me 2. So the vector a plus b is minus 1, 2. Right? All you're doing, you're adding corresponding values in the vectors. That's all you're doing. Nothing complicated. For part B now, part B, they want us to work out a minus b. So a minus b is equal to, and you're going to write down what the vectors a and b are again. So you're going to put 1 minus 2, and I'm going to subtract. I'm going to subtract minus 2, 4. Now there's a reason why I'm giving you questions with negative numbers inside here, right? CSEC loves to do that because they know students are going to make mistakes, right? So please be careful. So I'm going to subtract corresponding values. So this is 1, and I'm going to subtract minus 2. So 1 minus minus 2 is the same as saying 1 plus 2, right? So that will give me 3 on top, right? Then we need to work out the bottom piece. So we're going to say minus 2 minus 4. Minus 2 minus 4 is actually minus 6. So this is minus 6 here. So this is my answer for a minus b. The last one now. So even though students are able to work out a and b, sometimes they can get a little confused with this one. You have a plus 2b. So the first thing you write down is a plus 2b. Now you're going to write down what the vector A is. The vector A is 1 minus 2. So this is 1 minus 2 plus 2 multiplied by the vector B, which is minus 2, 4. So this 2b here is a scalar multiplication, right? So here's what you're going to do here now. So we're going to put 1 minus 2 first, and you're going to work out the scalar multiplication first. So this is going to be plus, and we have to take this 2 here, this 2, and multiply by this minus 2 first. So 2 by minus 2 gives me minus 4. And then you have to take that 2 and multiply it by this 4. So 2 by 4 gives me 8, right? So now we can do the addition now. So we're going to add corresponding values, right? So you're going to take 1 added 2 minus 4. 1 plus minus 4 gives me minus 3. And then you're going to add the bottom piece now. Minus 2 plus 8 gives me 6, right? So this is what the vector A plus 2b is. So, are we okay with this? All right, for those of you who joined the class late, the classes are recorded, so you can always go back to the YouTube channel. It may not be there right after. Just give it a 2 hours or so. It takes a while for YouTube to repackage the file itself, right? Also, for those of you who are here in this live class, what I want you to do, I want you to please, on the video itself, I want you to hit like, and I want you to hit subscribe, right? And please feel free to share my channel to anyone, right? Somebody asking something here. So if you go in that far, can you, yes, I have to, that is part of the slide actually. I'm not sure if I'll reach there today, but I have to do that as well. I need to talk about collinearity. Yes, I do, right? Okay, so let me just make sure you all understand this. So we're looking at this question here. We have 3 vectors. We have A, B, and C. And I want you to work out what the first part here. I want you to work out this first part for me. What is the answer for part 1? Right? So quickly work that out for me. What is the answer for part 1? All right, so I'm seeing Joshelle, Dyrell. All right, so I've seen people getting -1, 3, right? Let's see if we get that. So if you want to get A plus B, then so you're going to write A plus B, right? So I'm teaching you to write the proper statement. So A plus B is 2, 1, and B, in this case here, is -3, 2. So 2 plus -3 is the same as saying 2 minus 3, which is -1, and 1 plus 2 gives me. So this is the answer for part 1, right? -1, 3. See, most of you all getting this, so that means you all following what happened here. So the next one, we want to get A minus B. So I want the answer for question 2. Wow, they're moving real fast. Right? All right, so seeing some of you are getting minus 7, 3. See, Joshua got 1, 1. All right, so I've seen some similar answers. So we want to get a minus b. So you're going to write down what a is, which is 2, 1, minus 3 and 2. Now I'm deliberately giving you questions like these, right? Because this is what CXC is going to bring for you, right? Because I know students have trouble with dealing with questions with what we call directed numbers, right? So we're going to subtract corresponding values. So 2 minus 3. Oh, sorry, wait. I wrote the wrong thing, you know. Give me a sec. Yeah, I wrote the wrong thing, right? So it's b minus c we're trying to work out. So b minus c is minus 3, 2 minus c, which is 4 minus 1, right? So my bad there, right? So minus 3 minus 4 gives me minus 7, and 2 minus 1 is the same as saying 2 plus 1, so this is 3. So this answer here is minus 7, 3, right? So minus 7, 3. So that's the answer for question 2. What about the third one now, which is want to work out 2b minus c. So what's the answer for question 3? Right, so wow, you're all moving fast. So minus 10, 5, let's see. So you want to work out 2b minus c. So you're going to put 2 by whatever the vector b is, which is minus 3, 2. And what we're going to do, we're going to minus c, right? So minus 4, minus 1, right? So be careful. So we're going to take the 2 and multiply by each of the elements in the first vector. So 2 by minus 3 gives me minus 6, and 2 by 2 gives me 4. So this is one vector here. And we're going to subtract 4 minus 1. So minus 6 minus 4 gives me minus 10. And then 4 minus 1 is the same as saying 4 plus 1. So you're going to get minus 10, 5. Alright, so see, most of you all got that. Great job. Now, let me just give you a very important concept one time. If I have let's say I have something like this. So this is O, and I'm going to the point E, right? This is a vector here. And let's say that OA, that vector OA is, let's say it's 3, 4. Right? I'm just saying that. And I come and I ask you to tell me what is the vector AO. Right? So everybody in my class should know what this is, right? But I'm just asking this. What is the vector AO? Right, so students in my class, you should know what this is. What is the vector AO? Alright, so I'm seeing Joshua say -3, -4. Anybody else who actually in my class? Alright, so I've seen Emily saying -3, -4. Alright, so let's fix this one time. So look at something. If you want to go from O to A, what that means is that I would have had to go like this, across first, and then go up, right? So I would have gone 3 units up, 3 units across, and then 4 units up, right? That's why the vector is 3, 4. Now, if you want to go from A to O, or you want the vector AO, it means that I'm going in the opposite direction now. I want to go this way. Right? So the vector AO is in the opposite direction. So if we use the same principle to go from A to O, remember you always start in your X direction first. So let me use a different color. So you're going to go this way. You have to go across here first. And then you're going to have to come down here. Which means you would have had to go 3 units to the left and 4 units down. So therefore, the vector AO has to be, if you're going 3 units to the left, it's going to be -3. And 4 units down is going to be -4, right? So the vector AO is simply -3 -4, all right? That's what the vector AO is. So if you're moving, so let me give you an next example. If I tell you the vector OP is -2, 4, right? What is the vector PO? OP is -2, 4. What is the vector PO? Yeah, Riyadh, I will be doing that just now. Give me a sec. Come into that. Now, I know lots of students, they believe that vectors is very hard, right? To some extent, it requires some thinking, right? But if you draw the correct diagrams, it's going to be easy, right? When I did vectors the first time, however, how much long ago, I found it to be difficult, right? And the thing is, I started vectors not from maths first, but I started it from maths, right? And I found it to be rather difficult until I found my own way of trying to understand the question, right? Okay, so let's see. So you want a vector PO. All you really need to do to get the vector PO is just swap the signs, you know. So if this is -2, you're going to change this to 2. If this is 4, it's going to be -4. That's all you do. It's in the opposite direction. So you're putting a minus sign in front each of those two numbers, and you're going to get the vector in the opposite direction, right? So PO is 2 - 4. All right, so I think most of you all got that there. So it's 2 - 4. Great. What about, let's see. Now, this here is an extremely important concept that you need to know, right? It's called the triangle law of vectors, right? And this is how we add vectors that are not in the same direction, right? Now, I started off by talking about vectors and talking about moving from one position to the next, right? Now look at something here. The vector AC, right? AC is moving from this point here to this point, right? This is my vector AC. Now, I can go from A to C by an alternative route. I can go from A to B, so I can go from here to here, A to B, and then from B to C. It may seem very trivial what I'm showing you here, but it's a very important concept, right? Because in some books, when you look at how they give you the triangle law, you look at it and you be like, okay, yeah, I think I know what they're talking about. But when you start to do the questions, you realize you start to get confused. So I want you to understand it in terms of movements here. I want to go from A to C. If I want to go from A to C, there's another way that I can do it. I can go from A to B and then from B to C. So the vector AC is equal to A to B plus B to C. That's how we get in this formula here, right? So that's how. Let me ask you all something. What is, from this diagram, what is the vector AC in terms of a column vector? So look at the diagram and I want you to tell me what is the vector AC. Give me it in terms of a column vector. What is AC? So I want to know what is AC. So Daryl is saying 6 minus 1. Alright, so I'm seeing some 6 minus 1. So to go to the vector AC, remember this is how we do it. We say 1, 2, 3, 4, 5, 6 units to the right. So therefore it has to be positive 6. And then I'm going to go 1 unit downwards. So therefore it's 6, 1. I'm sorry, 6 minus 1, right? Because you're moving downwards, right? Once you go downwards, it's negative. So it's negative 1. What is the vector AB? What is the vector AB? Yeah, up here. Yeah, hit reload on your stream because you're probably getting the stream a little too late, right? Thanks, John. So what is the vector AB? Seeing somebody saying minus 5, 2. All right, now be careful, we always do the x direction first. So if we want to go from A to B, right, we need to go 1 across, then 2 across. So therefore this, and we're moving in the positive x direction, so this is 2. And then we're going to go 1, 2, 3, 4, 5. You're moving 5 down. So if you're moving 5 down, it has to be minus 5. So the vector AB is 2 minus 5. All right, so that is AB. Now I want you to tell me what is the vector BC. All right, so I'm seeing a lot of you all saying 4, 4. Let's see. So we want to go B to C. So we're going to go 1, 2, 3, 4 across. So therefore, this has to be 4. And then we're going to go 1, 2, 3, 4 up. So this is 4, right? So BC is that. Now, let's test and see if this equation that we wrote here is correct. So let's work out. So we know what AC is. AC is 6 minus 1. So let's work out AB plus BC. Right? So we add in two vectors here. So if we add in AB plus BC, AB is 2 minus 5 and BC is 4, 4. Right? So 2 plus 4 gives me 6 and minus 5 plus 4 gives me minus 1. So look at that. We got AB plus BC is 6 minus 1 and AC is also 6 minus 1. So therefore this statement here, right, this vector statement here is true. All right, so that's an important concept that we need to know. It's very, very important. All right, so one sec, let me get something here for you all. Right, so this is an actual exam question here, right? So you all are experts now. So we have position vectors. Anytime you hear the word position vectors, we're talking about a point in reference to my origin, right? At some point I mentioned that during the class. So when you hear position vectors, we're talking about O something. So OA, OB, OC. So they've given us 3 position vectors, OA, OB, and OC. They want us to find what is the vector AB. Now, there are many students, when they look at this, they'll be like, wow, what do we do? Right? So here's what you have to do. What you could do, you could draw a diagram and try to understand what's taking place. All right? The diagram doesn't necessarily have to be accurate, but we have 3 points. We have A, B, and C, and we have an origin O. Right? Now, so I have O, right? I just going to draw A, B, and C. Could be wrong like hell, but that's fine. So O, A, B, and C, right? So this is OA, this is OB, and this is OC, right? Now your diagram doesn't have to be correct, huh? It's just to help you visualize what's happening here. So look at something here. The question is asking, what is the vector AB, right? Now, I want to go from A to B. How else can I go from A to B? Anybody? How else can I go from A to B? Look at the diagram. The diagram is what helps us out to work this question. Right? So this is an exam question. All right, so Dyrell is saying go from A to O and then O to B. All right, and somebody already worked out what AB is. So Dyrell is saying go from A to O and then, right. So you want to find the vector AB, right? So you want to get this vector here. What is AB? In order to go from A to B, I can go from A to O and then from O to B. This is an important principle I'm showing you here. So if I want to go from A to B, I must start at A. I can go to O plus O to B. So the first thing we do when we write in our vector equation. So AB can be written as AO plus OB. Notice something here. This here represents my starting point, which is the same starting point as this. This is my ending point, which is B. Same thing here. And these two letters, they have to be the same. Keep that in mind. All right. So now I'm going to write down AO. Now there's a reason why previously I told you if I want to go in the opposite direction. You know what OA is. OA is 2 minus 2. So therefore AO will be minus 2, 2. Plus OB, which is 6, 1. This is 6, 1. So therefore this answer here is going to be minus 2 plus 6 gives me 4. And then 2 plus 1 gives me 3. Right? So this is the vector AB. Right? So you all double check my answer. Make sure it's correct. So it's AO plus OB. AO is in the opposite direction. So all you need to do, you need to put a minus sign in front of this. Put a minus sign in front of this. So this will become minus 2 and then this will become 2. And then we're going to add that to OB, which is 6, 1. So minus 2 plus 6 gives me 4. And then 2 plus 1 gives me 3. All right. So all right, so I'm not trying to complicate your life. I'm just trying to make your life as easy as possible, right? So some teachers may teach this differently. This is just how I do it. So the first thing from my diagram, I can see that AB is equal to AO plus OB. I can figure out what the vector AO is. It's in the opposite direction to OA, which is minus 2, 2. And then you already know the vector OB, so we just add in those two numbers. So the next part now, you want to figure out what is the vector AC. So AC is this vector here. So look at something here. I want you all to give me the vector equation. AC is equal to what? How can I write a vector AC in terms of vectors that I already know? Alright, so I'm seeing Joshua saying alright, so Joshua, just one comment there, right? I see him saying AC is equal to minus AO, right? It's really just AO plus OC. If you want to use the minus sign, then you're going to have to put minus OA, alright? So some teachers teach it like that, but I don't, right? So you want to get OC, right? So AC, right? So let me write it across here. So AC is the same as saying, look at something here. I want to go from A to C, but I can do this. I can go from A to O. I can go this way. And then from O to C. So AO plus OC, right? That's the vector equation we're looking for. So AO, you already know what AO is. AO is minus 2, 2 plus OC. OC in this case is 10, 4, right? So minus 2 plus 10 gives me 8 and 2 plus 4 gives me 6, right? So this is my vector AC. Yeah, so Joshua, if you understand that method, you stick to your method, all right? This is just how I do it, all right? But we're going to get the same answer either way. What else? All right, so that was just a sample question. I just want to introduce you to another concept before I move on. All right, we're going to look at some more questions just now. I just needed to understand this concept first. So, when we're dealing with vectors, we have vectors which are parallel, right? Just like how we have parallel lines, we have parallel vectors, right? So, parallel vectors, they give us a direction in which they don't ever cross, basically, right? So look at something here. I've given you three vectors. I've given you vector AB. If we look at the diagram, the vector is 4, 2. I've given you a vector CD, as this one here, which is 8, 4. And this one here, EF, which is 2, 1. All of those vectors, if we look at the diagram alone, we can see that those vectors are all parallel, right? Now, sometimes we can just be given the column vectors alone, no diagram. And we need to look at the column vectors and we have to be able to see if those vectors are parallel or not, right? Now, can anybody remember how can we tell if vectors are parallel? Yeah, boy, up here. Your stream is real delayed, boy. Alright, they're running same direction. Right, so that's what I'm looking for. So who is Jayla? It's multiples, right? When vectors are parallel, one vector can be written as a multiple of another vector. That's what I'm looking for here, right? That's a key thing you need to understand. Now, let me just go back here. So look at something here. The smallest vector that I have here is EF, right? So the vector EF is equal to 2, 1, right? Let's look at the vector CD. The vector CD is actually equal to 8, 4, right? But I can write that 8, 4 as, I can put 2, 1 here, and I can put a number in front of this. I can put 4 in front of this. So the vector CD is the same as saying 4 times whatever EF is, right? So we can see that the vector CD is a multiple of the vector EF, right? The vector EF is 2, 1, but CD can be written as 4 times that vector, right? So I can write CD as a multiple of EF. That tells me that the two vectors are parallel, right? Also, let's say AB. The vector AB is actually equal to 4, 2, but I can write that as 2, 1, and I can put a 2 here. And this will be 2 times what the vector EF is, right? This may be looking trivial, but you get a lot of marks for this in the exam because sometimes we have to prove that two vectors are parallel. Once you can prove that one vector, let's say I have a vector AB, is equal to K times some other vector, let's say K times CD, it means that the vector AB and CD are parallel. So once I can write a vector as a multiple of another vector, then they are parallel, right? So this is going to make a little more sense when I look at some of the questions, right? So let's get some questions, All right, so since your exam is primarily going to be more than likely a multiple choice exam, let me just give you something here, right? This is an actual exam from a multiple choice paper. I'll just take the diagram, yes. So look at this diagram here. So we have S, we have T, and we have P, right? So this is from a multiple choice paper. So this is the vector V, right? So this is another way to represent a vector with a little bar at the bottom. And this here is the vector U, right? So they give us P, S, and T, and they gave us the vectors U and V. And what do they want in this question? So they are telling us that U is 4, 3. So the vector U is equal to 4, 3. And the vector V is equal to minus 2, 1. Minus 2, 1, right? And the question is asking, what is the vector PT? So what is PT? Right? That's what the question is asking. And what they have here? So these are the answers. So part A is 2, 2. Part B is 2, 4. Part C is 6, 2 and 6, 4. So 6, 2 and 6, 4. All right. So this is an actual exam question here, right? So they give us a vector, a vector diagram. They give us the points P, S, and T, and they gave us the vectors U and V. What is the vector PT? So take a look at the question, look at the diagram, and see what you come up with. Give me an answer for this one. Yeah, up here. I'm not sure which country are you from, if it's Trinidad or anywhere in the Caribbean. Yeah, I'm not sure what's going on there. All right, so I'm seeing some answers. I'm seeing some people got B, Joshua got C. Anybody else? What about Kyle, Ronisha? All right, because I want to cover a little more, right? Let's work this question. So they've given us what the vectors u and v are, right? They've given us that. And they want us to find the vector pt. Before you can work out the vector pt, you must write the vector equation first of all. So you want to get pt, right? Look at the diagram. If you want to go from p, as this point here, to t, right? So you're going this way, right? Direction is extremely important here. So I want to go, the alternative way to get there is go from p to s. So it could be ps plus s to t, right? So a lot of people don't realize that you can get this equation straight from the diagram. There's nothing to think about here. You're looking at the diagram and coming up with the equation, right? Some people, they try to remember formulas, what they learned in class. Please look at the diagram. The answer is right there. So PS, the vector PS is actually the vector u. That's what they say. Plus ST, which is the vector V. But you know what u is and you know what v is. U, they told you, is 4, 3. Plus the vector v, which is minus 2, 1. So 4 plus minus 2 gives me 4 minus 2, which is 2. And then 3 plus 1 gives me 4, right? So the answer is 2, 4, which is B. So the answer for this question here is B. All right. Let's do our next one here now. For this particular question, please, 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 I will say it again, pay attention to this question. We have a vector P, and the vector P is 3, 2. So this is 3, 2. We have a vector Q, which is minus 1, 4. So we have a vector Q, which is minus 1, 4. So it's minus 1, 4. The minus 1 is on top. Actually, hold on. Let me just, I don't like how this is looking. So P is 3, 2. And Q is equal to minus 1, 4. Right? So we have two vectors here, P and Q. And what the question wants us to work out, right? This again is an exam question. So they want us to work out P minus Q. P minus 2Q. Right? That's what the question is asking. And these are my answers. So A is 110. A is 110. B is 1 minus 6. C is 510. And D is 5 minus 6. All right. So the question wants us to work out P minus 2Q. What's the answer for this question? Oh, up here. Wow. Yeah, that's kind of far away. Right? All right, so like I said, pay attention to this question, especially for your July exam. Do not get it wrong. All right, so seeing Kyle and everybody else saying D. Let's see. So here's what we want to work out. You want to work out P minus 2Q, right? That's what you want to work out. So P in this case here is 32 minus 2 times whatever Q is, which is minus 1, 4. So this is 32. Now they deliberately brought this question because they know students having problems with this. So leave the minus sign as is, don't touch it. Take the 2 and multiply by this here. So you're going to get minus 2 and you're going to get 4 2s are 8 here, right? So all I did there was work out this here first, work out 2Q. Work out that part first, right? So then what you're going to end up with is 3 minus minus 2, which is the same as saying 3 plus 2, which gives me 5. And then 2 minus 8 gives me minus 6, right? So the answer is actually D. All right, so you all are correct. All right, so somebody asked me just about a parallelogram. Let's look at this question here. So I have a parallelogram here. All right, this is the next question as well. So we have a parallelogram which is W, X, Y, and Z, right? So we have a parallelogram there. And what else do we know? We know that XY is U. Okay. So XY is equal to U and XW is equal to V, right? This is what they are telling us in the question. They want, and R is the midpoint of YZ. So point R is the midpoint of YZ. So the question wants to know, what is WR? Right? So what is WR? Again, pay attention to this question. Make sure you know how to answer it. So it's U minus a half V. So this is U minus a half V as A. B is U plus a half V. So this is U plus a half V. C is minus U plus a half V. Minus U plus a half V. And D is minus a half V minus U. Minus a half V minus U. Alright, so we have a question here. We have a parallelogram and we want to figure out what is WR. Right, so take a look at this question. Look at the parallelogram. So the question wants what is WR, right? So this is W here and this is R here. So the question wants to know what is this vector, right? That's what the question is asking. What is that vector? Right, this is a very tricky question. Some students will get it wrong. Right, so I've seen two people saying B. Now wait until I get some more answers before I work it out. Alright, so I'm seeing people in my class saying E. Alright, I'm seeing Emily, John, Xavier, Renisha. Alright, so let me explain how we work in this one. So first thing, we have a parallelogram, right? So because I have a parallelogram and they also give me some known vectors, right? So let's start. So we know what the vector xw is. So xw, right, is equal to v, right? They told us that. Told us that in the question. xw is equal to v. Now, because it's a parallelogram, right? This side here, xw has to be parallel to yz, right? So if I know xw is v, I know that yz is equal to v as well. I know that because it's a parallelogram, right? Also, they give us the vector xy. Xy is u. So xy is equal to u, right? Now, xy is equal to u, which means that the vector wz, that's this vector here, wz is equal to u, right? So wz is equal to u. So we can make these statements because we are dealing with a parallelogram, right? Now, let's try to focus now. Let's see what's going on here. You want to find the vector WR, right? That's this vector here. That's what the question wants, right? You have two ways you can get to WR. You can go from W to X. You can go this way. You can go this way and then come this way. That's one way, right? But that seems a little too complicated for me. If I want to go from W to R, so the question wants W to R, right? So let's look at it. W to R is equal to, I can go from W to Z and then from Z to R. Does that equation make sense? Before I move on, I just want to make sure, does that equation make sense? WR is equal to WZ plus ZR. Right? So don't try to learn off any formula. I'm getting this information from the diagram. I'm not doing anything complicated. I'm looking at the diagram. So I just want to know, does my equation make sense? All right. So I'm getting that information from the diagram. I'm not doing anything crazy as yet. I'm not doing anything as yet. Now, let's see. Do we know the vector WZ? As far as I can tell, yeah, we know that. That's this. WZ is this vector here, right? But do I know what ZR is? We need to figure out what ZR is. We know that the point R, right? They told us that the point R is the midpoint of YZ, which means that Y is sitting in the middle of R and Z, right? Now, let's see if we can figure out what ZR is first before I do the addition. So ZR, right? Direction is important, people. So ZR is this way. Yeah? So you know what ZY is? ZY is actually not ZY. You know what YZ is? YZ is equal to V, right? So therefore, from this, I can say that ZY is equal to minus V, right? So YZ is equal to V, therefore ZY is equal to minus V. Now ZR is actually a half ZY, right? So ZR is equal to a half ZY because the point R is between Z and Y. So this is equal to a half multiplied by ZY, but look at ZY. ZY is equal to minus V. So this is going to be V and a minus sign here. So now let's go back to the original equation we have. So WR is equal to WZ, which we know, that's this. That's U. So this is U plus ZR. I just work out ZR. ZR is this. Plus minus a half V. So therefore my answer is U minus a half V. So the answer is actually A. Please, please, please pay attention to this question. Do not get it wrong in July. All right. So I know some of you all probably real lost here. So first thing, they told us it's a parallelogram. That means something, right? So they've given us what xy is, and they've given us xw. They've given us xy as being equal to u, and xw as being equal to v, right? And they also give us another piece of information here, which is this. R is equal to the midpoint of yz. So R is in the middle. This is where R is. And the question wants us to find what is this vector here? WR. What is this vector here? Right? That's what the question wants. So as far as we know, WR is actually equal to WZ plus ZR. That's what this equation is what I'm starting with. That's what I need to use to figure it out. Right? Now, because it's a parallelogram and you know what XW is, you know what YZ is. The two vectors will be the same. So if XW is equal to V, then YZ is also equal to V. If we know XY, then we know what WZ is. If XY is U, then WZ is equal to U as well, right? What I suggest you do is replay this part of the video to try to understand it after, okay? Now, I need to know what ZR is in order to figure this out. But ZR is going in this direction. Direction is important. ZR is going this way, right? So ZR is actually the midpoint. So this is what I'm going to use to find ZR. ZR is the middle of Y and Z. So this ZR is equal to a half ZY, right? And we know what ZY is. ZY is actually minus V, right? It's not V. ZY is actually minus V. So therefore, you can work out what ZR is here. So that's what I'm doing there to work out this here. So then all I'm going to do is add those two vectors. So WR is equal to U minus a half V. All right. So I'll do more questions first of all, right? To make sure. Let me get a next question for you. Don't feel discouraged, please, right? Do not feel discouraged. Let me get a next question for you. Let me show you how these questions Just give me a minute, right? Let's take a step back here. Let's go back to something that you are a little more comfortable with. So what I will do in the next class next week, I will give you some more questions similar to that, right? I don't want you all to feel like vectors is too hard now, right? So look at this question here. We have a triangle. This is an exam question as well. ABC is a triangle, and they've given us the coordinates of A, B, and C respectively, right? These are the coordinates. The first thing they want us to do in part A is to write in the form the position vectors of A, B, and C, right? So that part is straightforward. There's nothing to do there. So position vectors OA, all you're going to do is to write this as 2, 2. OB is equal to 6, 2. And OC is equal to 4, 6, right? All I'm using here, I'm just using the coordinates they've given us here. That's what I'm doing. Now, what I want you all to work out now, the question wants to know what is the vector AB. So I want you all to tell me what is the answer for this one here. What is the vector AB using the information they give us this? All right, so for those of you who didn't understand the last question, next week I'll do more questions on vectors, right? But what I want you all to work out right now, I want you to work out the vector AB. All right, so seeing some of you all getting answers already. So the first thing we need to do, right, make sure you have a diagram that you can follow. So we have my origin, right? I don't know where A, B, and C is, and I don't really care. So A, B, and C. So this is A, this is B, and this is C, right? This is for you to understand what's going on, right? So this is OA, this is OB, and this is OC. So the question wants to find the vector AB, right? So they want this vector here, AB. So if I want to go from A, that's this point, to this point, then I must go AO plus OB, right? Can I do this here? Right? So AB is equal to AO plus OB, right? So all of these questions, you start off by writing a vector equation first of all. So the vector AO, we know what OA is. OA is 2, 2. So if we want AO, which is in the opposite direction, is going to be minus 2, plus OB, which is 6, 2, right? When I add this up, I'm going to get minus 2 plus 6 gives me 4. And minus 2 plus 2 gives me 0. So the vector AB is actually 4, 0. Yes, this is a paper 2 question. Right? So the answer is 4, 0 for AB. Right? So that's the answer for this part here. 4, 0. What I want you all to work out now is work out the vector AC. Giselle, yeah, I may not be doing any paper 3 because almost all the students in my class, they have SBA marks already, right? All right, so I'm seeing some answers like 2, 4. So if you want to get the vector AC, that is from here to here, that's AC, I can go from A to O and then O to C. So the vector AC is equal to AO plus OC, right? AO in this case here, we know what AO is. It's minus 2 minus 2 plus OC, which is 4, 6. Right? Minus 2 plus 4 gives me 2, and minus 2 plus 6 gives me 4. So the answer is 2, 4. All right. Alicia, yes, so this is my Form 5 class here that I just opened up for some people to just see what we do, right? Yes, we are doing multiple choice. We've already done probably about 8 multiple choice exams already, right? But that's only for who's in my class, right? On my website, I've already been doing e-testing long before CXC started theirs, right? But this is my final review with my class for vectors and vectors. We did matrices already. This is for vectors. This is to make sure that they can answer any question that comes in the exam. Whether the format of the multiple choice is slightly different, they will be able to answer the question, right? So the answer is 2, 4 for the vector AC, right? And then the last one here, they want the vector BC. So BC, according to my diagram, is this. So if I want to find the vector BC, BC is equal to, from the diagram, BO plus OC. So BO, we're going in the opposite direction, so it's minus 6 minus 2 plus OC, which is 4, 6. So minus 6 plus 4 gives me minus 2. And minus 2 plus 6 gives me 4. So the answer is minus 2, 4 for this one. All right. Yeah, Giselle, I'm from Trinidad. All right, so BC is minus 2, 4. Okay, so we got the answers for those 3 parts. Now, this last part here, right, which is the last part I'm going to do, they want us to show by a vector method that the triangle ABC is isosceles, right? How do we know if a triangle is isosceles? What is an isosceles triangle? Anybody, what is an isosceles triangle? You'll stand zone out on my man. Alright, two sides are equal, one side is unequal. That's correct. We're looking for Alright, so two sides are equal. Let me see something here now. So if you want to prove, right, using a vector method, right, that it's an isosceles triangle. So we don't know how exactly how the triangle is going to look. We just know that we have the sides A, B, and C, right? And if it's an isosceles triangle, two lengths have to be the same. So what we need to do, we need to find the length AB, because we know how to find the length of a vector. We can find the magnitude of AB. We can find, so that's this length here. We can find this length here, which is BC. So we can find the magnitude of BC. And we can also find the magnitude of AC, right? That's what we're doing. And if you look carefully, we have all the lengths. That's what we just worked out here now. We have the lengths in terms of a vector. So AB was 4, 0. So AB is 4, 0. Right, this is a 0. AC is 2, 4. So AC is equal to 2, 4. And the last one is BC, which is minus 2, 4. BC is equal to minus 2, 4. Right? So all we need to do, we need to find the magnitude of AB, right, which is the length of AB, which will be equal to 4 squared plus 0 squared, and we find the square root, right? So remember, I gave you all the formula to find the length, right? So this is really 16, square root of 16, which is 4. So this is 4 units. So the length AB is 4 units. Then we need to work out AC, which is 2 squared plus 4 squared, square root, which is equal to 2 2s are 4 plus 16 square root, which is really the square root of 20. You don't need to work this out. You could just leave it as the square root of 20 units, right? You can if you want, it's up to you. And then BC is equal to minus 2 squared plus 4 squared, square root. Minus 2 squared gives me 4. 4 squared is 16, square root, and this is 20. Right? So this is square root of 20 units. So if you notice here, we've worked out the lengths of the triangle, and you realize that this one here is the square root of 20, and this one here is the square root of 20. So the fact that AC, the magnitude of AC, is equal to BC, we can say that triangle ABC is an isosceles triangle. All right. So we've covered most of what you all need to know for vectors, right? Basically, that's the material that you need to know. So what I'm going to do next week, all right, we're going to go through some more questions, right? I'm gonna say more questions. You see how you all had problem with that multiple choice question? We're gonna do some more like that, and hopefully you all be able to get it, right? So at the next class, I'm still continuing with vectors. I'm gonna look at examination questions to make sure you understand basically any question they bring, you'll be able to answer it. All right. So that'll be it for today. I hope the session was productive, right? If any of you all are interested in getting access to my platform where you can practice in multiple choice exams, just send me a WhatsApp, right? Yes, somebody's asking about physics. Yes, we are doing that right now with my Form 5 class, but that's only for my class. All right. All right, so that's it for today. I hope the session was productive. So you guys take it easy and be safe.